Hello everybody, today we are going to start our 5th unit in algebra, which is the systems of equation unit. Today, in today's lesson, we are going to be learning how to find the solution of equations by graphing. So you could assume that today we are going to be doing lots of graphing. So let's look at the do now. The do now says, what is the name of the coordinate point? Okay, as soon as I think of coordinate point, I think that I'm going to need an x value and I'm going to need a y value where both of these equations intersect. If we remember, to find the x value, you look how much left and right, and to find the y value, you look how much up and down. So I want the name where they intersect. If you know intersect, that's where two lines cross, the point where they cross, and they cross right here. And to get to that point from the 0, 0 line, I had to go to the left 1, which that would make it -1. And I had to go down 1, 2. If I went down 2, that would be -2. Another question that can be asked is, what quadrant is the point where they intersect? If you remember to name quadrants, we call this the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So where does it intersect? It intersects in the third quadrant. All right, that's just a little review. All right, let's get into what are systems of equations. A system of linear equations, so right now we're just worried about linear equations, so those are straight lines. We're just worried about linear equations, consist of two or more linear equations. In this algebra 1, we're only going to worry about 2 equations, made up of 2 or more variables, so in this one we're only going to have 2 variables, such that all equations in this system are considered simultaneously, meaning we're going to consider them together. Some of them are going to have one solution, some of them are going to have no solutions, or some of them are going to have many solutions. Most commonly, we'll see ones that have one solution. All right, so seeing if a solution is true or false, a question can ask, is this the solution to the system of equations? So, the solution to a system of equations in 2 variables is the ordered pair x, y. We check if this solution is correct by substituting the value in for x and y and use a calculator to find out if this solution is true or not. For it to be a solution, it must be true for both equations. So let's say these are our equations and the point is x equals 4 and y equals 7. Let's see if this is true. For this one, I would have 2. Instead of x, I would put 4 plus, instead of y, I would put 7, maybe equals 15. Well, let's see. 2 times 4 is 12, and 12 plus 7 is 15, so 15 does equal 15. So far, we are good. But for it to be true, both of them have to have that same point. So let's look here. 3, instead of x, I'm going to put 4, minus y, which is 7, maybe equals 5. 3 times 4 is 12. 12 minus 5 does equal 5. 12 minus 7 equals 5, so we are good. So we would say, yes, this is a solution to the system of equations. This is the point that lies on both of the graphed equations, and this is where they intersect, so that is the solution. All right. Now I want you guys to try this one. Determine whether the ordered pair 5, 1 is a solution to the given systems of equations. So pause the video and try this one. So here x equals 5 and y equals 1. So let's try this. We would have, instead of x, we would put 5 plus 3. Instead of y, we would put 1. Maybe equals 8. Let's see. 5 plus 3 times 1 is 3. And that does equal 8. 8 equals 8, so we are good so far. But we don't know that we're good until we check that both equations this point works. Let's check the next one. We would have 2. Instead of x, I'm going to put 5 minus 9, hopefully equals 1. Let's see. 10 minus 9 does equal 1. 1 equals 1. We are good. All right, so this is a solution to the given systems of equations. And let's just do one more of these quickly. Determine whether this point is a solution. You could pause the video and try it again. So here, x equals 9 and y equals -2. Let's try this. Here we are saying y equals -2 over 3 times x, which is 9, plus 4. Well, this, oh, and we know that y is -2. So we need to see, is this true? -2 equals -6 plus 4. -6 plus 4 is -2. So this is true so far. Now let's try this one. X is 9 plus 4 times y, which is -2. And we need it to equal 1 maybe. That will be 9. 4 times -2 is -8 equals 1. And 1 does equal 1. Alright, so we just seen 3 examples where the ordered pair does work. The only time it wouldn't work is when one of them didn't become true at the end. When you were left with just 2 values, like we were left with -2 equals -2, but you would have one where it didn't work out. Alright, now, what are the type of linear systems we could have? The first one we could have is something we call an independent system. An independent system is one that has exactly one solution. This means that the two lines intersect with just one point. So if you draw 2 lines, they're going to intersect once. So that would be called an independent system. They have one solution. Now the next kind of system we could have is an inconsistent system. Inconsistent system. This is where there would be no solution, meaning that the lines are parallel. I'll show you an example of parallel. Think of the equal sign, and they will never intersect. For example, if you draw these 2 lines, they are never ever going to intersect. They're going to keep going to the left and the right, but never will they get crooked where they will intersect. So that is called an inconsistent system because they have no solution. And the last one is called an dependent system, which has infinitely many solutions. This means that every coordinate pair is the same. So basically, if I graphed this and then went ahead and graphed this one, those are both the same exact line, which means they cross at every single point. So that's a dependent system because they have many solutions. Alrighty. So what do they look like? Independent system is one that has just one point. An inconsistent means no. And a dependent means that we graphed 2 things on these lines, the same exact point, so they cross every single place, so they have many solutions. Now today we're going to practice graphing 2 different lines and see what kind of system they are, how many answers do they have. Alright, so to solve systems of equations by graphing, we can determine the type of system by graphing each equation on the same set of axes. Depending on how many times the 2 equations intersect, that will tell us how many solutions there are, and that will help us determine which type of system it is. Alright, so let's try here. I like graphing these because they're already in y equals, so this makes it easier. First, I'm going to graph this first one. Y equals 3x minus 4. This means I'm going to start at -4, so I'm going to go down 4 and put a point. Then my slope is 3 over 1, meaning I go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. 1, 2, 3, over 1. Can't go up no more. Let me go down. Down 3, to the left 1. Down 3, to the left 1. And now, let's connect these points and put an arrow, and I'm going to label it. Right down here, I'm going to put y equals 3x minus 4. Just so if I was somebody coming to grade this paper, I would know what I was doing. Alright, let's graph this one. My y-intercept is 3, so I'm going to go up 3 and put a point. And then my slope is -1 over 2, which means go down 1 to the left 2. To the right 2. Down 1 to the right 2. Make sure your line looks like it's going down. And go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Beautiful. Now connect these points. We're going to put our arrows. Beautiful. So now, to identify the solution, because that's part of the question, we need to name the point where they intersect. So the solution is right here. And to get to that point, we went to the right 2 and up 2. So our solution is 2, 2. So this would be a solution that only has one answer. It only crosses once. Alright, let's try this one. I still like this one because it's already in y equals, making my life easier. So let's try this one. All right. We are going to go down 2 and put our point, and then the slope is -1/2. So down 1, right 2, down 1, right 2, and then up 1, left 2, up 1. Make sure our line looks like it's going down since we have a negative slope. Connect the points. And let's write right next to it, y equals -1/2 x minus 2. And let's try this one. My y-intercept is a +2, which means I'm going to start by going up 2. And then my slope is -3/2. So down 3 to the right 2. 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 Then up 3 to the left 2. Up 3 to the left 2. Okay, now let's connect these points. Put our arrows, and let's label it y equals -3/2x plus 2. Now, to identify the solution, we need to say where do these two cross. They cross right there. So the solution is 1, 2, 3, 4, and then down 1, 2, 3, 4. And if they wanted to know what quadrant this is in, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So you would say that the solution is quadrant 4. All right, let's try this one. Ooh, this is a little challenge one because neither of the equations are in y equals. So pause this video and try to get this equation and both of these equations in y equals. Starting with the first one, to get rid of this x, we would subtract x, and we would get y equals -1x plus 4. Now this one, we need to get rid of that 4x, so subtract 4x. We would get -3y is equal to -4x plus 9, and then divide by the -3. Y equals 4/3x minus 3. All right, let's graph the first one. Our y-intercept is 4, so go up to 4, and then we're just going down 1, right 1, down 1, right 1. All right, when you label it, you want to label it with whatever the original equation was, because you know that equation is right, so label it with the original one. And let's try this one. Down 3, put a point, and then up 4, because positive 1, 2, 3, 4, and to the right 3. Up 4, to the right 3, up 4, to the right 3. All right, let's connect these points. And let's label it with the original equation, which was 4x minus 3y equals 9. And to name the solution, we need to find where do they cross. To get to that point, I went to the right 3 and up 1. Perfect. All right. Now let's look at this application problem real quick, a word problem. It says, a recreation center ordered a total of 15 tricycles and bicycles. Let me write down what I know now. I know that the number of tricycles plus the number of bicycles equals 15. Number of tricycles plus the number of bicycles equals 15. Okay? Then it says the number of wheels for all tricycles and bicycles equals 38. Wheels of tri plus the wheels of bi equals 38. Write a linear system of equations that models this scenario, where t represents the number of tricycles and b represents the number of bicycles. Okay, I definitely do not know how many tricycles and bicycles they ordered. I could assume numbers, but I don't know for sure. So I'm just going to write t plus b equals 15. Now let's think, do I know anything about wheels? Well, I definitely know that every tricycle has 3 wheels. So I'm going to put 3t plus. And I definitely know that every bicycle has 2 wheels, so that would be 2b equals 38. And that would be our system. Now, to solve this, tomorrow we will learn how to do it algebraically, but if you wanted to do it today. Alright, so now we're going to do an application problem. An application problem is this problem right here. We already figured out the equation, t plus b equals 15. And then we have the equation 3t plus 2b equals 38. So in order to graph this, we have to decide, do we want to make this t or b equals? So remember how our normal equations are always y equals? Let's look at the y-axis. The y-axis is the vertical axis. Here our vertical axis is b, which means we need to get this equation to be b equals. So in this first one, we need to bring t to the other side. It's a positive t, so we're just going to subtract t. So then we would have b equals, do not do 15 minus 1 because those are not like terms, so we are just going to have negative 1t plus 15. Alright, so now to graph that, we start at our y-intercept, which was 15. So 15 would be in between 16 and 14. That's 15. And now negative 1t would be down 1 over 1. Down 1 to the right 1. And we're going to fill up this whole entire graph just because we don't know how far we're going to have to go with the next equation. So fill up the whole entire graph until we get to the bottom. And we are going to connect the points. We are not going to put an arrow at the bottom because we're never going to get lower than 0. So that's it. That's our final equation. Now let's look at this next one, the number of wheels equation. 3t plus 2b equals 38. We need to get b by itself. So to get rid of 3t, we're going to subtract 3t, which would give us 2b equals negative 3t plus 38. And now to get rid of that 2 is being multiplied by b, so we're going to divide by 2, and we'll get b equals negative 3 over 2t, and then 38 divided by 2 is 19. Alright, so for this equation, we're going to have to start at 19. 19 is right over 18, and then we're going to have to go down 3 to the left, right 2. Down 3 to the right 2, and keep going the whole entire length of the graph. Ooh, I found my point where they cross. Nice. Continue going down 3 to the right 2, down 3 to the right 2. Now we are going to connect these points. We do not need to put arrows because once it's at 0, that's it. We can't go into the negatives. We can't have negative number of bicycles or tricycles. And those are our two equations. Now the point where they intersect is right here. It is, we went to the right 8. So that would be 8, and we went up 7. Remember here, our first number is t, and the second is b, which means that the correct answer is 8 tricycles and 7 bicycles. So it is not true that he ordered 10 tricycles. And why is that? If we look at 10 tricycles, the equations don't cross at 10 tricycles, so that would not be our answer. Alright, and now to finish up this lesson, let's just look at our summary. The first question for our summary is, what is a system of equations? A system of equations is whenever we have more than one equation that we're considering together on the same graph. Here we're always going to be talking about 2 equations. What does the solution to a system of equation looks like? It looks like the point where they cross. The point where they intersect, we say. The point where both equations intersect. Okay? Then what are the 3 different types of systems? Well, we could have this system that has one solution. We could have this system that has no solutions because they're parallel lines. Or we could have the solution where you graph 2 lines that are the same exact thing on top of each other. And that one would have many solutions. So that is the end of our systems of equations solving by graphing lesson. Thank you.